University, I know 7 members are there, my friends
Okay, actually, the
in
picture
Bangalore.
is my friend who was working there in Geetham. He left and went to Christ. So his position was
Oh,
vacant. His position was
yes.
vacant. He told me to send my resume. I sent my resume.
Ah,
And then they told me to register my profile in their website.
okay.
And then they told me to give the some reference number after I register in the website.
Yeah, you can give my number.
No, no, I mean, in the sense, after I submit my profile in the Geetham University website, that will generate a reference number. After
Okay.
submitting that
Okay.
reference number, I have to email to the, I think, a HR,
Ah,
and
okay.
then they will schedule. So what my friend said is, if you do that, they will immediately arrange the interview. So before that, you study the concepts and be prepared, and then you send the reference so that it will be convincing for you to present.
Okay. Okay, no problem. Can
So,
you? Yeah, no problem.
yeah.
It's okay.
So can I start, sir?
Yeah, yeah, please. What is
Okay.
machine learning?
Yeah, just a minute, sir. Let it start. Okay. So, very good evening, sir. I'm just
Good evening.
going to present
Yeah.
kind of a brief talk about machine learning and its
Yes.
impact
Yeah.
in day-to-day's life. So, machine learning is a subset of artificial intelligence
Correct.
that enable the system to use the labeled data
Correct.
to predict the outcome.
Correct.
Um, or to make some decisions. With that, the system can better itself for the requirements. So the
Correct.
machine learning can be said in three types:
Correct.
sequential learning,
Supervised learning.
sorry,
Supervised learning.
yeah, supervised learning, unsupervised learning, reinforcement learning.
Correct.
So when it comes to supervised learning, it is actually based on the labeled data. Um, to predict the future
Correct. Future
and
value based on the past values.
past value. And when it comes to unstructured data, sorry, when
Unsupervised
it comes
learning.
to
Ah,
yeah, when it comes to structure, it is basically, when it comes to supervised learning, it is basically training the model based on the labeled data to predict the future. And when it comes to unstructured learning, identifies the patterns and structures in unlabeled data, such as clustering and dimensionality reduction.
correct.
Yeah, when it comes to reinforcement learning,
Ah,
it is completely based on
punishment and
training.
reward.
Yeah, training the agents based on the punishments and reward or trial and error method. It is basically to optimize the sequential, learning pattern for the task.
Very good. Very good. Correct.
Yeah, and when it comes to the applications of machine learning, it is healthcare, basically to detect the or predict the disease spread of a person. When it comes to finance, it is all about fraud reduction, and when it comes to
Correct.
autonomous vehicle, it
Correct.
is self-driving cars.
Correct.
So if you ask me a question, how does the machine learning works? Um, Basically, the machine learning has a wide variety of complex algorithms that what do you call learn the data.
Correct.
It can be labeled data or unlabeled data
Correct.
uh, to predict the future outcomes.
Correct.
And there is a way the data are trained, and the trained data are given. Trained data are used to uh, what do you call produce a model,
Hmm.
and from the model, what do you call analysis is done, and then retraining is done. If the model does not produce the expected outcomes,
Correct.
uh, you know, retraining is done.
Hmm.
Once the retraining is done, again the model is tested,
Correct.
and then the better results are expected. So likewise, n number of trials may happen before a model is completely produced and then given for the customer's use.
Correct.
Yeah. So when it comes to again supervised learning, it has classification and regression.
Correct.
And regression is logistic regression, linear regression. When it comes to classification, support vector machine, Navy's Bayes, K nearest neighbor.
Correct.
And then unsupervised learning is based on clustering and dimensionality reduction. Again,
Correct.
clustering is based on means shift, and then K means algorithms, and then principal component analysis, and then linear discriminant analysis. When it comes to what I call reinforcement learning, um, uh, learning queue algorithm is used, and then DQN is used, decision queue network algorithm is used, etc.
Very
So
good.
this is what I was able to recall, sir.
Okay, no, but you are telling very good, Ramchand. Please
Okay,
continue.
okay, sir. Uh, so after which, I think till this I was able to recall. I remember.
Okay. Can you try by seeing this slide? No?
Yeah, yeah, I can try, sir.
Yeah, please try.
So machine learning is the subfield of artificial intelligence.
Correct.
So the goal of machine learning generally is to understand the structure of data. So basically, there may be different types of data, but the goal of machine learning is to understand what the data is and where the data can fit into and how the data can be used to design the models,
Correct.
and so that it can be understood by the people.
Correct. Now tell me.
So when we talk about machine learning here, there are many things that needs to be always keep it in mind. One is what, why, and then how the process of machine learning is applied
Correct.
and where it is practiced, and then we have to understand the theoretical concepts.
Correct.
Yeah. So when it comes to why is all about self-driving cars in terms of autonomous vehicles, uh, chatbots used in applications to help the people to get insight into the websites, and then because there are many people who may not know where to browse and how to browse. So
Correct.
chatting with the chatbots will help them to understand the required informations, and then movie recommendations. So when it comes to movie recommendations, this will give brief insights about scientific fiction movies, and then most importantly, the spam reduction in Gmails, which is a major threatening factor.
Correct.
There are so many what do you call hazard emails that keeps hiding in the spam emails that may spoil the inbox at any point of time, or to hack our important email conversations like bank transfer details, etc.
Correct.
And then when it comes to the process of applied ML, data cleaning and exploration.
Correct.
So basically, data cleaning is all about filtering the bad data
Correct.
or unwanted data,
Correct.
and then exploring it for the proper usage purpose. And then feature engineering is basically where and how to apply the data
Correct.
at the right cost for a right expected outcomes.
Correct.
And
Correct.
then outlier treatment. This I don't know, sir. Outlier treatment.
Outlier means normal behavior is not there. Suppose in a SBI bank account, per
Uh,
day transaction limit is
yeah, yeah,
1
yes,
lakh.
sir. Yes, sir. I recall. Now I recall your
Yeah,
example. You
please
told
tell me.
me. You told me in the very third class, I think.
Very good, very good.
Yes, yes. So in the outlier
Abnormal,
reduction,
yeah.
yeah, abnormal behavior of a transaction
Person.
in a particular account
Perfect, perfect,
details.
perfect. Correct.
Yes, yes, sir.
Mm.
And then missing value treatment,
Mm.
which is basically, let's say when we are trying to predict, the future forecast,
Ah,
if some important key values are missing from the past data,
ah.
so this will be identified and it will be applied.
Correct.
And then data modeling. Data modeling is basically data can be of different types. It can be structured, unstructured, semi-structured. So depending upon the requirement, the data can be feed into the model to find the expected outcomes.
Ah,
Uh, if the outcomes is not satisfying us, then we can retrain the model to get the better outcomes in the n number of trials. And then model validation is all about once the model is properly designed, we have to test the model to make
correct.
sure that the model is a valid model for the customer's use.
Correct.
And then evaluation. So at the time of evaluation, it can be through feedback of different customers' usage, or
Correct.
feedback of superior, person in the team,
Correct.
or feedback of colleagues, through which the model can be evaluated and redesigned, or added features can be uh, merged in the existing package. And then
Perfect.
model deployment is for the public use, or for the systems exploitation and its
Correct.
uses.
Correct. Correct.
And then practice.
Mm.
So practice, machine learning can be practiced with the help of joining different communities,
Correct.
by sharing the knowledge, and then sharing the expertise and things like that.
Mm.
And then learn from the experts will always give deeper insight into what we need for the future.
Mm.
So this one, sir, Kegel's concept.
Which one?
The in participate
Mm.
in practice, participate Kegel's contents.
Uh, where is
The
the?
third one, sir.
Where is the?
Practice, sir. Third one, sir.
Under
Third one.
practice, what is your doubt? Please tell me.
I do not know what this topic is. Practice Kegel's content.
Kaggle, that is Kaggle contents. Huh?
Okay. Yeah.
నేను క్లాస్లో ఉన్నా మళ్ళీ చేస్తాలే ఉండు. మ్మ్. మ్మ్. అది లైట్ ఆఫ్ చేస్తే కొంచెం మబ్బుగా ఉంటుంది అనేసి. ఓకే. ఆ, ఓకే నేను క్లాస్లో ఉన్నా మళ్ళీ చేస్తా. రామ్చంద్, వాట్ ఈజ్ యువర్ డౌట్?
Yes,
పార్టిసిపేట్
sir. The
క్యాగల్.
third one, sir.
టెల్ మీ.
Yeah, I do not understand what the third one is.
Yeah.
Participate.
Participate in Kaggle contents is nothing but Kaggle is a repository. We are
Yes, sir.
we are downloading many data sets from Kaggle. Kaggle is a repository where we are downloading data sets.
Okay, sir. Okay, sir.
That's all. Next, continue.
Okay. And then listen to podcast.
Mm.
Um, so I'm sorry, podcast also I don't remember.
Uh, which one? Podcast
The next
means
one, sir.
you are
Yeah.
explaining something related to your topic, and with mic you are explaining. That is called podcast, like
Okay.
radio listening podcast.
Okay, sir. Okay.
Next.
Okay. And then subscribe to newsletters,
Ah,
which give insights about machine learning. Will help to
mm,
develop our knowledge.
correct.
Uh, and then learn Toolbo.
Correct.
So okay, with the help of Python,
Python and R.
uh,
Mm,
yeah, these are the library files that will help us to work with the machine learning concepts
correct.
for implementation.
For Python, we have a number of packages like Keras, TensorFlow, Scikit-learn, Pandas, NumPy. In
Yes,
R
sir.
programming, we have MLR and DPLYR and Caret. Like that, you need to tell. Tell me.
Yeah,
Next.
and then theory,
Ah,
multivariate calculus,
correct.
algorithm and complexity,
Ah,
optimization, probability theory and statistics, linear algebra. These are all the very important topics,
correct.
and that needs insights to understand the model that we design for the public's use. So
Correct.
in-depth knowledge is very much important.
Okay, perfect. Next.
Yes, sir.
There
And
are
then
three
when
types
it
of machine learning techniques.
Yeah, supervised learning, unsupervised learning, and reinforcement learning.
Mm.
So when it comes to supervised learning, it is basically, we try to train a model based on the label data
Ah,
by using, regression and classification. Whereas in unsupervised learning, there will be unlabeled data.
ah,
We'll be using we'll be using those unlabeled data to find the patterns or structures
mm,
with the clusters and the um, dimensionality reductions.
mm.
And then the reinforcement learning, based on the punishment and rewards or a trial and error
Correct.
method, we always try to better the previous models.
Correct.
It is basically like providing what I call updated versions of upgraded models.
Correct. Next.
So when we talk about machine learning again, so the supervised learning is simply called as task driven,
Correct.
whereas unsupervised learning is simply called as data
Data
driven.
driven.
and the reinforcement learning is all about learning from mistakes, that is
Correct.
learning from errors.
Perfect.
And yeah, so this is we said. Yeah, next slide, sir.
Same thing we are explaining in the types of machine learning.
Yes, sir.
Supervised learning is a task driven, unsupervised learning is a data driven,
Data driven.
reinforcement.
Reinforcement learning is learning from the errors or
Perfect,
mistakes.
perfect. Next,
Yeah.
machine learning process.
So when we come to machine learning process, so we try to train. I mean, we have a big data.
Correct.
Here it is basically a huge volume of data with data cubes. So with those data, we try to train a big model,
Hmm.
and then the model will produce some outputs, and that outputs is given to applications, and the we can expect a query from the applications. Again, the big model will serve the what I call query to the applications.
Correct.
Yeah, yes, sir.
Next.
So when we come to machine learning again, it is a kind of a cycle. The first is to gather the data, basically
Correct.
to collect the data from different source, and then prepare the data. Data preparation is basically all about segregating the data depending upon the structured, unstructured, or semi-structured data, and then put those data into data wrangling. And it is a kind of filtering or purifying the data, and then put those data into analysis to analyze where the data can be used, how the data can be used, what the data will do, will it serve to the requirements on all those stuffs, and then input the data into a model, train the model. Once the model is trained, test the model to make sure that it will satisfy the user requirements, and
Correct.
finally deploy the model for public use.
Perfect. Perfect explanation.
Yeah.
How
And
machine
then
learning work?
how does the machine learning work?
Hmm.
The machine learning will work basically from an inputted data. The data can be of any type of data, but the data will be analyzed, and then the data will be filtered depending upon the quality of the data, and then try to find some patterns from those data. Once the pattern is found, something can be predicted. If nothing is predicted, again the process the process will be done again and again for several number of steps to predict something, and then store the what you call feedbacks is basically for upgrading the model into the next level of to the next level of usage.
Correct.
Yes, sir.
Next.
And then machine learning examples are self-driving, that is
Cars.
autonomous vehicle,
Correct.
and then credit card worthiness.
Hmm.
Worthiness in the sense like it also will help us for detecting a fraud in terms of protecting the credit card and alerting the people
Correct.
when it is used by a hacking person. And then computer vision in agriculture, which is the very which is the latest trend in applying the machine learning concepts in agriculture, to save the resource and manpower, as well as to save the resource, and also economically it supports to the larger extent. And then question and answer based platforms also machine learning supports, and then predicting illness for healthcare, and then ranking on social media about any person, any channels, YouTube channels, or any
Correct.
uh, anything that it is all about people's interest about certain things,
Correct.
and then targeted emails, and then fashion industry.
Correct.
Yes, sir.
Second concept with mathematical.
Yeah, mathematical foundations for machine learning.
Correct.
The first one is algebra,
Uh,
where vectors, matrices, and eigenvalues are
Eigenvalues.
eigenvalues are very much important. Uh, so
To
can you just
solve
tell me this? Yeah.
to solve complex applications.
Okay, to solve complex applications. Whereas probability and statistics is very, very vital.
Hmm.
If and only if somebody has a good knowledge of probability and statistics, the basics of machine learning can be understood, examined, and then implementations can be done with a strong knowledge of probability and statistics.
Perfect.
And then optimization techniques is always very, very vital, because any model that is designed should be very much optimal Optimal in the sense, in terms of economy, in terms of usability, in
Mm.
terms of easiness.
Correct.
Optimal techniques like a gradient descent,
Ah,
convex optimization will
perfect.
really help to better the model for the easy
Perfect.
usage of the system.
Perfect explanation. Next, third.
Yeah. And then supervised learning algorithms such as linear regression, logistic regression, they both plays a very vital role in classifying the binary data, like bringing out either ones and zeros as results, like true and false.
Mm. Perfect.
And then decision trees or random forest.
Mm.
Decision trees actually split the data based on the feature value to make predictions.
Mm.
It is actually divide the trees into two groups, and then while random forests improve the accuracy by combining multiple decisions,
Correct.
trees for better generalization.
Mm.
And then support vector machine finds optimal hyperplane to separate data points into different classes,
Mm.
maximizing the margin between them for a effective classification.
Correct.
And then neural networks, artificial neural network.
Mm.
It is something similar to our brain,
Mm.
where we have neurons
Mm.
through which the inputs are given. Our eyes see the
Ah,
things, and then whatever the eyes see, that takes as input, and then it
correct.
gives input to our brain with neurons. The same is the case in this
Correct.
case. There are so many hidden layers that do the computation with the inputted data to process the output.
Correct. Next, unsupervised learning.
Yeah, unsupervised learning, clustering, where
Ah.
K means hierarchical
No, no, first
clustering.
you need to tell unsupervised learning is nothing but there is
Okay,
no target class. Chip. Tell me.
yeah, there is no target class, there is no label,
Correct.
but we used to,
Euclidean
predict.
distance.
Yeah, we
Similarity
used to
measure.
predict the pattern
Ah.
um, and predict the outcomes,
Ah.
and then the yes, sir, the
Based on the
Euclidean distance.
similarity measure, we have
Yes, sir.
2 points like x1, x2, y1, y2.
Yes,
Similarity
sir.
measure Euclidean distance formula is square root of x1 minus x2 whole square plus
Plus
y1
y1
minus y2
minus
whole square.
y2 whole square.
Perfect, perfect. Next, continue.
Yeah. And then principal component analysis,
Ah.
the dimensionality reduction. So basically, when we talk about dimensionality reduction,
Hmm.
let's say, for example, if some five
In
to six
face
pictures are given,
recognition. Ah.
yeah, 5 to 6 pictures are given for a person's face,
Correct,
trying to understand or trying to minimize or maximize the pixels, to increase the width or height of the image,
correct,
adjust the nose, trying to eliminate the moles, and then trying to eliminate the black spots in the faces to
correct.
give a better clarity in the lookup of the face.
Perfect. Next.
Yeah, and then association rule mining using a priori algorithm, FP growth
Ah.
algorithm is to identify the relationship between the variables in a huge, large data sets.
Correct.
Basically, when it comes to the market basket. So, can I say this example like a customer is frequently by purchasing certain items,
Correct.
and then trying
Correct.
to figure out a pattern of his purchase depending
Ah.
upon the
100%
seasons.
correct.
Yeah,
Yes.
depending upon the month, depending
Correct.
upon the festival
Behavior of
seasons
the
like that.
customer. Behavior of the customer.
Okay, sir. Behavior of the customer.
There
Okay,
we
sir.
are using two types of clustering, I mean association rule mining algorithms. One is a
Okay.
priori algorithm and a frequent pattern. FU means frequent pattern growth algorithm. That's all.
Okay, sir.
Okay,
Okay, sir.
perfect explanation. Excellent.
Okay, sir. And
Next.
then, yeah, deep learning and neural networks.
Uh,
So, fundamentals of deep learning neural networks is all about, and it's a network consists of multiple layers
uh,
of interconnected neurons that learn the complex patterns from large data sets.
uh,
It can be n number of layers. We cannot predict the what we call hidden layers,
mm,
but the size may vary depending upon the complex inputs which is inputted into the system.
mm,
Yeah, and then convolutional neural network for
perfect.
image, for image processing. It is designed for image and
Uh,
spatial data processing using conventional layers
perfect.
to detect patterns like edges, textures, and objects in the image.
Perfect.
Yeah, and then recurrent neural network for sequential data.
Correct.
So it is all about it is used in natural language.
Processing.
processing by maintaining the hidden states to capture dependencies between the previous and current inputs.
What is natural language processing? Study of linguistics. You need to tell
Mm.
like that.
Okay, sir. Okay, sir.
Different study of different languages is called NLP.
Okay, sir.
Okay, next continue.
Yeah. Yeah, and then transfer models and attention mechanism.
Mechanisms.
Sir, this one, please tell me, sir. I was not able
Yeah,
to.
transfer models like machine learning is a one type of model. Deep learning is a one type of model. So this is extension of machine and deep learning. We have a transfer modeling. It is the latest concept in deep learning, powered by self attention mechanism, efficiently process sequential data in parallel, and are widely used in natural language applications like one we are converting one language to another language, one speech audio to another speech audio by using BERT and GPT, generative pre-trained transformer, for text understanding and generation. There we are using transformer models.
Okay,
Very
sir.
good, very good. Next, Ramchand.
Yeah.
Feature engineering.
Uh,
Hmm.
Yeah, feature engineering and data processing.
Ah.
So handling the missing data.
Ah.
Let's say, for example, when we compute mean, median, and mode, there are chances we might have not, obtained the expected results. So in such cases, this computation is redone to find the missed data, or what do you call assumption, what do you call data with assumptions are used to fit into the function, and then try recomputing to find the expected values of mean, median, and mode.
Correct.
And then future scaling and the normalization.
Hmm.
So it is basically, so normalization comes under database management, no, sir?
Ah, yes, perfect, perfect
Yeah,
correlation
yeah.
to
So when it
remove
comes to,
the redundant data.
yeah, yeah.
Perfect.
So we have first normal form, second normal form,
Ah,
voice code normal form,
perfect.
uh, etc. So in every stages of normal form, so we try to what do you call bring the uniqueness of the value to the model so that the
Correct.
model will function based on the
Correct.
requirements.
Correct.
Mhm. And then encoding categorical data.
Mm.
So categorical variables are transformed into numerical form using encoding methods
Mm.
like one hot encoding,
Ah,
label encoding, the target encoding to make them suitable for machine learning algorithms.
correct. You
So
just
basically,
remember
so,
encoding, you
okay,
tell we are converting one form to another form. That's all. Nothing else.
okay, sir,
Mm.
okay, sir. Yeah, and then feature selection technique.
Mm.
So when we come to feature selection technique, we might have used a different type of model to train
Correct.
and to find the expected outcome,
Mm.
but we may find different outcomes, but the outcomes that the best suits to the customers or to a system will be chosen as the best product.
Correct. Correct.
Yeah.
Next, seventh
Yes.
model.
So model evaluation and performance metrics.
What is model?
So
How can you
model is
define model?
basically, yeah, model is
Simplified
basically
version of the reality.
simplified version of the reality.
Perfect. Perfect.
Yes. Okay. So when it comes to before we employ a model for
Mm.
public's use,
Correct.
but we have to do a lot of testing. We may obtain positive results, sometimes negative results.
Correct.
So this what do you call confusion matrix,
Correct.
precision, recall,
Ah.
and then FN score will
Correct.
always be used to
Correct.
bring out the best of the expected results.
Correct.
Yeah. And then ROC curve, the receiver operating characteristic
Characteristic. That is ROC,
curve.
receiver
Yeah.
character.
So it illustrates the trade-off between the sensitivity and the
Specificity.
specificity. Sir, what is the difference, sir? I forgot this.
Yeah. ROC says that how it is behaving, like trade-offs means what is the minimum value and maximum value, like sensitive value and specificity value. Like 0 to 100 it will solve, that is called a sensitivity. And
Okay, sir.
specificity says that area under curve models overall ability to distinguish between classes. Okay, it solves so and so particular 0 to 50 it will solve, 50 to 100 it will solve, like that. That is called AUC, area under curve. Next, cross validation.
Okay, so cross-validation techniques such as k-fold cross-validation will help to evaluate a model performance on different data subsets while understanding the basic variance trade-offs, ensures an optimal balance between the underfitting and overfitting. So if it is underfitting, then which is not fitting the requirement to say the model is a complete model. If it is overfitting, maybe it is like supporting more than what it is expected from a model. Is that like that, sir?
Yes, yes, correct, correct, correct.
Okay. And then hyperparameter tuning,
Hmm.
grid search, random search.
Correct.
So these are the two types of search that will try to improve the accuracy and the generalization on the unseen data.
Correct.
Yes, sir.
Next,
Then
ensemble learning.
so ensemble learning and advanced machine learning techniques. So, sir, this you please
Yeah,
recall me,
no
sir.
problem. Bagging and boosting, these are the two, you can call it as a, it is a classification techniques under the machine learning algorithm. Bagging reduces variance of, how do you can calculate variance, in matrices? Variance.
Mm,
Difference
I
between
studied, sir.
yeah, difference between one row to another row, like in two matrices we are calculating differences between one matrix to another matrix is called variance by training multiple models in parallel, while boosting sequentially corrects errors by focusing on misclassified instances, like 100 items, you are classifying male versus female, but two persons are not classified, that is called misclassified. Maybe they are third gender, like
Oh,
yeah, misclassified
okay, sir.
instances. With that, with that algorithms like ADA boost and gradient boosting and XZ enhancing model performance, we are solving the required solutions. Next, stacking
Okay.
and blending techniques like stacking and blending combine predictions from multiple models using meta learners, where stacking employs secondary model to learn optimal combinations, and blending uses weighted averaging for improved accuracy. Like there are plenty of applications we are solving under multiple models using meta learners. So we are using under ensemble learning, machine learning techniques like auto ML and automated feature engineering. We are using end-to-end process by model selection, hyperparameter tuning, and feature engineering, and making machine learning more accessible and efficient for non-experts. Next, Ramchand, can you explain reinforcement learning? Any doubt, please ask me. Please
Yeah,
explain.
sure, sir.
Yeah,
Yeah, sure, sir. So, reinforcement learning with the help of Markov decision process,
correct,
it provides a mathematical framework for making decisions in environments with stochastic outcomes.
correct,
Basically, when we try training the agents, there are chances where the agents may not function according to the expected outcomes. If that is the case, based
correct,
on the punishment and reward, the model will be once again trained. I mean, the agent will be once again trained to see whether it is solving the requirement.
correct,
Q learning and deep Q learning. So
correct,
Q learning is a value-based reinforcement learning algorithm that updates Q values for optimal policy selection.
perfect,
Whereas deep Q learning networks leverage neural networks to approximate Q values for a complex environments. So
perfect.
basically, both works for the complex environments.
Very good,
To
Ramchand.
find,
Very good
yeah,
explanation.
yeah, to find the optimality, policy that suits the requirement,
Correct.
and then policy gradient methods. So here also we look for
Policy means rules and regulations. Keep in mind. That's all. Nothing
yeah,
else.
yeah. So the rules and regulations should support the model
Ah,
to solve the expected outcomes.
correct. Perfect
Yes,
answer.
sir.
Next.
Yes, sir. Yeah, the next slide, sir.
Yeah,
Okay.
applications.
applications and case studies in machine learning.
Ah.
So NLP is the first and
Study
foremost
of
application.
different languages is called NLP.
Yes, sir. Yes, sir.
Ah.
Let's say, for example, when we say chatbots,
Ah.
chatbots should not only support English, it should
Correct.
also support Chinese, Russian, French.
Correct.
So any person with a different language skills will be using any website.
Perfect.
So
Perfect answer.
the the chatbots should be supporting any person that speaks a different language to
Correct.
communicate or to interact with.
Perfect
And then
answer.
computer vision. The best example is, let's say, agriculture.
Audio,
Nowadays, machine
video,
learning.
text,
Yeah,
graphics, animation
graphic
combination is called
animations.
computer vision.
Let me just try say an example. Let's
Ah.
say, for example, agriculture is one
Ah.
of the best application
Perfect.
for machine
Perfect.
learning. Why? Because nowadays, the let's say, for example, if a plant is sorry, if a seed is planted and 5 to 6 months, the seed can be grown
Correct.
and to be harvested. So in such cases,
Mm.
yeah, it is completely monitoring the growth and the quality of the thing can be monitored by the image recognition for a research purpose,
Perfect.
with the help of image analysis and
Perfect.
techniques.
Perfect.
And then fraud detection and financial modeling.
Ah. Mm.
Let's say, for example, I use my credit card
Ah.
elsewhere else on online,
Mm.
purchasing. There are
Perfect.
chances where my
Correct.
data are hacked, and
Ah.
what do you call? So such hacking is monitored, and then the information is alerted to the user
Correct.
with the help of machine learning concepts.
Correct.
And then healthcare is basically to predict the patient's disease spread in the body,
Correct.
etc.
Perfect. Perfect. Next, coming
Yes,
to
sir.
supervised learning, we have 10 top 10 algorithms of what is meant by supervised learning? How you can define Ramchan?
Yeah. So when it comes to supervised learning, it uses the label data to train a model
Correct.
for
Correct.
tasks like regression and classification.
Correct. So
Yes, sir.
there is a label, there is a target class, but I would like to classify the data based on the
Yes, sir.
label, based on the target class. Like we have 10 types of supervised learning techniques: linear regression, logistic regression, decision trees, random forest, support vector machine, k nearest neighbor, naive bayes, gradient boosting, that is called GBM, XGBoost, light GBM, cat boost, artificial neural networks, that is called ANN, ridge and lasso regression. Okay, tell me
Yeah.
what is meant by supervised learning. What you
Yeah.
understood, Ramchan?
So just now that's what we were talking
See,
about.
why
So
I
it
am
is
asking
basically,
deliberately instead of my explanation. You are
yeah.
going for interview. That's why I want to justify whether you are giving correct answer or not. That is my aim. That's all.
Yeah, yes, sir. Yes, sir.
Yeah,
Right.
please.
So, I mean, basically, the supervised learning uses the label data to train a model
Correct.
for the tasks such as regression and classification.
Correct.
So, when it comes to regression, it is all about predicting a continuous variable.
Ah, correct.
Yeah, yeah. For example, let's say predicting the price of a house based
Correct.
on its features. Features in the sense like
Size,
location.
location.
Yeah, location matters, size matters, and then the locality where what do you call groceries, shopping malls, and stuffs. So I mean, these are the parameters where we input into the system to find the best price for the house that we are looking in for a certain location. Yeah. And then the next one is spam email detection.
Correct.
So basically, there are hazardous email that can be hidden in the spam. There are chances the spam email can harm our what do you call email inbox by what do you call capturing our important conversation. Let's say the bank transaction details, etc., etc.
Mm.
So the supervised learning are the ones that will help us to find out by using the regression techniques.
Correct.
And then simple linear regression.
Mm.
Let's say it fits a straight line to data points, predicting the student's score based on the study hours.
Mm.
In fact, you had also explained with a Python code
Correct.
to say when a student, I think
Perfect.
from 60 to 140 was the
If he
score,
studies
and
2 hours, he is getting 60
yeah,
marks.
Yes, and from 2 hours to I think 11 hours,
Yeah,
the marks vary from 60 to 140.
correct, correct, right.
So similarly, we can also predict the lifespan of a person, but still that is under research, is what you
Yeah,
had said.
yeah,
And then
perfect.
multiple linear regression
Mm,
extends the simple linear regression to consider multiple features. So in
correct.
the previous case, like let's say very few inputs. In the third case,
Mm.
multiple inputs from different dimensions
Like
for an
size,
extended output.
weight, and fuel type.
Yes,
Perfect.
sir. Yes, sir.
Perfect, perfect. Next, continue.
Yeah, and then
Ridge
uh, ridge,
regression.
ridge regression. So it reduces the complexity of the model by adding
Correct,
a penalty term.
correct,
So predicting house prices while avoiding overfitting. Okay,
correct,
overfitting is basically okay. Without, I mean, overfitting in the sense extra features are added into the house to increase the price and then to advertise, and then for a better advertisement to sell the product.
correct.
And then logistic logistic regression is basically used for a binary classification problems. Okay, predicting if a tumor is malignant or benign, isn't it, sir?
Yes,
Yeah.
correct.
So basically, the availability of the tumor or the size of the tumor. So all such things are predicted based on logistic regression. And then K nearest neighbor. So it classifies a data point based on how its neighbors are classified. Um, Recommending a movie based on a user preference. Let's say, for example, based on media, based on yeah, so and so media, it gives what you call ratings to different movies. So it can be a science fiction movie or it can be any type of a movie, but based on the prediction, it gives recommendation for the customer to enjoy a movie in a theater.
Yes,
And then Navy-based classifier assumes feature independence and uses Bayes theorem.
correct.
Text classification for spam detection.
Okay, next.
And then LDA, linear discriminant analysis, used for dimensionality reduction or classification. I think I had given an example trying to, uh, what you call, give the perfectness to a compromised picture to give a better clarity in the lookup, and then maybe classifying wine types based on the features like acidity and sugar content.
Correct,
Um, and then support vector machine finds the hyperplane that best divides a data set into classes. So
correct,
classifying whether a person will go on a default loan or not. Let's say, for example, I'm a person constantly, making things happen at home by applying loans. But still, I do make a proper repayment at the month of, let's say, at the third of every month. So
correct,
my complete payment is completely monitored by, machine to give what you call feedback to the loan manager saying that this person is not a default person. He makes everything on time, so this person
correct,
can be sanctioned so and so loan.
correct,
And then decision tree.
correct,
So uses a tree-like graph to make decisions,
mm,
predicting the likelihood of a customer for buying a product.
correct. Perfect
Uh,
answer.
yeah.
Next.
And then Bayes variance trade-off. A model with high bias oversimplifies where high variance overcomplicates. Let's say a linear model might underfit a complex data, whereas a high degree polynomial might overfit. So it's basically what you call uh, trying to compel to fit into the one where it does not fit,
Correct,
or the other way, trying to compel to unfit the one where something is fitting.
correct.
Yeah.
Perfect answer.
So there are some explanations I'm just trying to give
No,
on
no,
my
no.
own.
I'm checking each and every. Your
Uh,
explanation is
um,
correlating to my topic. Then only I will
okay.
say yes. Otherwise, I will say no.
Okay, sir. Okay, sir.
Next.
Yeah. Cross validation methods.
Mm.
Leave one out and k-fold. This is a technique to train a model and validate a model.
Ah,
Basically, in k-fold, k may be any number, dividing the data set into k subsets. So basically, we divide them. It is like a divide and conquer, like dividing the set into number of sets
ah,
and rotating them for validation.
correct.
Yeah, and then multi-layer perceptron or and feed-forward neural network.
Correct.
So this is basically artificial neural network for complex problems
Hmm.
to picturize the handwritten digital
Perfect.
recognition.
Perfect answer. Next.
Yeah. And
Top
then
10
top 10 supervised learning algorithms.
like linear regression.
Linear regression.
Uh,
So I think this I think I had explained already. I think.
all you have explained. Once again, you can
Yeah. Yes, sir.
explain, no problem.
Okay. Okay. So linear regression is used for regression task to predict continuous values.
Perfect.
Yeah, whereas logistic regression for binary classification problems by estimating the probabilities,
Correct.
either 0 or 1. And then support vector machine, it's
Uh,
for effective for high dimensional spaces and
correct.
binary or multi-class classification.
Correct.
And then decision trees. So basically, it is split into branches of two different trees for classification or regression.
Uh,
And then random forest, an ensemble method combining multiple decision to improve
uh,
performance.
correct.
And then gradient boosting machines, XGBoost, Light GBM.
Correct.
So powerful ensemble models using sequential decision trees to minimize errors.
Perfect. Next, naive
Okay.
base.
Um, Navy Bayes,
Hmm.
based on Bayesian's theorem, ideal for text classification and spam detection. And then K nearest neighbor classifies data points based on their proximity to neighbors in a feature space.
Hmm.
Sir, can we say the square root of x1 minus x to
Ah,
the whole square plus y1 minus y
yes,
to the whole
yes,
square?
that is applicable. Yes,
Yeah.
perfect answer.
And then linear discriminant analysis
Hmm.
projects data to maximize
Projects,
class.
projection alla.
Yeah.
Projects.
Okay, projects data to maximize class separability for classification task.
Perfect.
And then multi-layer perceptron, a type of feed-forward neural network for regression and classification.
Correct.
Elastic net regression combines L1 and L2 regularization for a linear regression.
Hmm.
So basically, it does do the combining work. So ridge regression,
Hmm.
linear regression with L2 regularization to prevent overfitting. Okay.
Correct.
So basically, it stops adding on extra things. And
Correct.
then lasso regression, linear regression with L1 regularization to enforce sparsity
Perfect.
in features. Okay.
Correct.
Yeah.
Coming to
And then,
unsupervised learning, explain a
yes, sir.
definition of unsupervised learning. How you can
Okay.
define?
Yeah. So basically, unsupervised learning identifies patterns and structures
Correct.
from the unlabeled data, such as
Correct.
clustering and
Like
dimensionality
audio,
reduction.
video, text, graphics,
Text
animation.
bugs.
Perfect
Yes, sir.
answer, Ramchand. You are
Yes,
so
sir.
outstanding. Next.
Thank you, sir. Thank
Yeah.
you for encouraging me.
Yeah, you are explaining outstanding. Next.
Okay. Okay. Thank you. Yeah. So we have K means clustering.
There are 10
Uh,
top 10 algorithms of unsupervised learning. We don't
okay,
know
sir.
target class, we don't know label name, but we would like to classify the data based on the similarity measure you need to tell. How do you
Okay,
can
sir.
calculate similarity measure? By using Euclidean distance, Manhattan distance and Minkowski distance. We have 2 points like x1, x2, y1, y2. We are calculating similarity measure by using Euclidean distance called square root of x1 minus x2 whole square plus y1 minus y2 whole square. If you tell like that, they will clap you like anything. Okay.
Okay, sir.
Yeah,
Okay, sir.
please tell me now. Now repeat
Yeah.
that one. What is
Okay.
unsupervised learning? I'm asking
Yeah.
once again.
Yeah. So unsupervised learning is all about we don't have label, we don't have
Correct.
target class,
Perfect.
but we are trying to predict the patterns
Perfect.
and
Perfect.
structures. Yeah, based on the clustering and
Similarity
the
measure.
dimensionality. Yeah, similarity measures.
Hmm. We have two
Uh,
points like x1, x2, y1,
yeah,
y2.
and by one by two.
By
Yes, sir.
using Euclidean distance, we have a
By
formula
use
called
Yeah,
square root of.
by
Uh,
using the Euclidean distance, we have an equation called square root of x1
x1
minus
minus
x to the
x2
whole
whole
square,
square plus y1 minus
square plus
y2 whole
y1 minus y to the whole
perfect
square.
perfect appudu if you
Yes,
tell like that they will impress like anything while you are giving interview They will
Okay, sir.
impress like anything. Oh, this boy
Okay, sir.
knows everything like that.
Okay, sir.
Next,
Sure, sir.
these are the top 10 algorithms. You can read
Yeah.
all the algorithms once again.
Yeah, sure, sir. K-means clustering,
Hmm.
hierarchical clustering, density-based spatial clustering of applications with
Hmm.
noise,
Hmm.
Gaussian mixture models,
Perfect.
principal component analysis, independent component analysis,
Hmm.
autoencoders,
Hmm.
self-organizing maps,
Hmm.
a priori algorithm, T-distributed stochastic neighbor embedding.
Perfect. Perfect. Coming to
Yeah, coming
unsupervised
to
learning.
unsupervised
Hmm.
learning. So we have clustering algorithms.
Perfect.
Basically, it is for grouping the data points based on the similarities.
Correct.
Example, customer segmentation for targeted marketing.
Correct.
Um, let's say, for example, people who live in a lower class, people who live in a, let's say, middle class,
Hmm.
their taste of purchasing is different.
Correct.
And during the seasonal timings, again, the, purchase varies, from what do you call, people belongs to different religion, different class, so on and so forth. And then next comes to
Hmm.
K-means or K-medoid, partitioning data into K clusters. Example, document clustering based on topics. Let's say we have a number of topics, out of which one, a certain group of topics may belongs to artificial intelligence research. Certain group of topics may belongs to cybersecurity research. So something
Correct.
like that, we split based on the patterns of data.
Correct.
And then hierarchical clustering.
Perfect.
Either it is from the top-down approach or based on the bottom-up approach.
Perfect.
Bottom-up approach is based on single linkage and multiple linkage. Um, so basically, builds a hierarchy of clusters, hierarchical taxonomy of animal species,
Perfect. Perfect. Next,
and then
dimensionality reduction.
yeah, dimensionality reduction, reducing the number of features while retaining the important information. So when we try to say, for example, we have what I call um, let's say for example we are trying to search some identity of a person. We have blurred the image of a person. So first what we try to do is, among the five pictures that we have, the best picture that we keep as a constant value, from that picture we try to identify the missing portions or the blurred portions of certain images, and try to identify the correct picture of a person by adjusting the dimensionality value.
Oh, yes.
Okay, and then principal component analysis. It transforms the original variable into new ones that are linearly uncorrelated. Basically, trying to reduce the dimension of gene expression data.
Correct.
And then top 10 unsupervised learning algorithms. K means clustering. So basically, it groups the data points into K clusters based on feature similarity. And then hierarchical clustering builds a hierarchy of clusters using either, sir, what is this, sir? Agglometric
It is a clustering algorithms. Agglomerate
uh,
cluster. Yeah.
or divisive method. The next one is density-based spatial clustering of applications with noise. If this one groups data points based on density, identify clusters of arbitrary shape. So arbitrary is all about the different shapes, is it, sir?
Yes. Yes.
Okay. And then Gaussian mixture models
Hmm.
fix data into multiple Gaussian distribution to form soft clusters. And then principal component analysis reduces dimensionality while preserving variance by protecting data onto orthogonal components.
Perfect.
And then independent component analysis separates a multivariate signal into additive subcomponents based on statistical independence. Whereas autoencoders is a term mostly used in neural networks used for dimensionality reductions and feature learning.
Correct.
And then T-distributed stochastic neighbor embedding, a visualization algorithm for high dimensional data by reducing it to two or three dimensions. And then a priori algorithm identifies frequent item sets and
Correct.
association rules in transaction data. Whereas isolation forests detect anomalies by randomly partitioning data and isolating anomalies in fewer steps.
Correct.
Yes,
Next.
sir. Uh, and then I mean, reinforcement learning. Reinforcement learning is all about trying to train agents so that the agents can perform according to the expected needs. Not only that, it is also based on punishment and rewards. It is also based on trial and error method, basically to optimize the sequential decision making task. So there are 10 types of reinforcement learning: Q learning, deep Q networks, state action reward, state action, policy gradient methods, actor critic, A to C and A3C, advantage actor critic, proximal policy optimization, trust region policy optimization, and then Monte Carlo methods, a deep deterministic policy gradient, and then soft actor critic. These are the
Yes.
10 important reinforcement learning algorithms.
Yes.
Yeah, so reinforcement learning, it is a type of a machine learning where the agents are trained to learn to make decisions by interacting with the environment, by receiving the feedback in the form of punishment and rewards, or simply we call it as rewards or penalties to maximize cumulative rewards over time. Because we may have a number of trials, so we keep trying to increase the performance of the system so that the system will support the best needs. Yeah.
Huh.
Uh,
Perfect.
Yeah, sir, actually it's 4 o'clock. I have to leave.
Oh, oh, sorry,
Yeah,
sorry, Ramchand. One second.
yes, sir.
Yeah, yeah. Can we stop here?